Okay, welcome. So today what we're going to be discussing is piecewise functions. And before I go ahead and describe piecewise functions, what I want to do is just kind of start with a warm-up of graphing some functions and kind of looking at this restriction. So previously, what we have discussed in our work in functions has just been, understanding a function, understanding the domain, and really understanding the implied domain. Basically, really seeing like when a function is defined and, more importantly, like when is the function undefined. And so far with the implied domain, we really only looked at the restrictions that a function cannot be, divided by 0, or you can't take the square root of a negative number. So we look for values that made the function undefined and helping us define the domain. So in this warm-up, what we're basically going to do is it asks us to graph the functions and then change the graph based on the domain restriction. So you can see here I have a function and then I have a domain restriction. So what we're going to do is we're going to just graph it as we know, and then we're going to apply the domain restriction, and I'll show you how to do that. I also provided a link to the graphs on Desmo, so you can go ahead and kind of take a look, and we can also check our answers. Now, the main important thing to give you a little heads up for today's lesson on piecewise functions, last lesson we talked about transformations of functions as well as the parent graphs and like domain and range a lot. That's going to be very, very important. So if you're a little like shaky on that information, I would highly recommend making sure that you have at least covered that or have that printed out next to you. So therefore, as you're going through this, you can kind of refer to it as you need, because I'm going to graph all of these with the assumption that we can graph them based on our lesson from last class period. So I'll work a little bit kind of quicker, through these just to make sure we can kind of get through it, but I will explain my steps. So if I wanted to graph y equals negative x squared minus 1, knowing the parent graph, I know that this is going to be a parabola. And then knowing the transformations, I can see that this is going to be a reflection about the x-axis, and this is going to be shifting 1 unit down. So just graphing it with no, no restrictions, it's going to look something like this. Something like that. Now I got to look at this domain restriction. Now this domain restriction says I only want you to graph this function only for values when x is less than or equal to 0. So remember, here's the x-axis. So we're only graphing it for x values that are less than 0. That means all that x values that are going to be negative. So therefore, anything to the right of the y-axis means the x value is positive, meaning it's not going to be a part of this function. So what I need to do is just graph, jeez, I knew that was going to happen. It's so tough to be able to do that. So what I'm going to need to do is graph this function for only values that are to the right of the y-axis. So I'll have to recreate it, and it looks something like that. Now, the important thing to notice is I included a point here because what I wanted you to understand is that 0 is defined, right? When it says x is, why did I do that again? All values, these are not true, right? My brain is like wants to make those points. It's x is less than or equal to 0, which I said, I just didn't graph it correctly. So these values are what's good. Sorry. But it's important that you have this point here because that x equals 0 is included because as x is less than or equal to 0 is my domain restriction. So that is what my graph is going to look like. And again, we can kind of go to the link here. And if you look at the normal graph here, which I provided, and then if you just kind of look at the domain restriction now, you can see that it's the graph, at a horizontal shift -1, and then it's moving down to the left. All right, so now let's go and work on the next one. Now the next one, again, has some transformations, which I think, gets confusing a lot of times. So we might want to rewrite this as y equals negative x plus 1. And again, sometimes that still doesn't do enough justice, but we notice that we have a negative on the inside, so that's going to be a reflection about the y-axis. And then we have a horizontal shift. But again, when we have a b as well as a horizontal shift, we got to be careful. We want to factor out that b. So as I factor out a negative, all right, now you can see that my horizontal shift is actually 1 unit to the right. That's why it's important to factor that out. Now, furthermore, this reflection about the y-axis actually is not going to be affecting our graph because the absolute value function is an even function. If you take this graph and reflect it about the y-axis, well, the graph is symmetrical about the y-axis. So actually having this symmetry doesn't really affect, the shape of the graph. But what it does do is it does mess with our transformations because a lot of students if we didn't have that plus, then it'd be shifting 1 unit to left. But the fact that we have that negative there, we have to factor it out. We can see that this graph is actually being shifted 1 unit to the right. So the graph, oops, let me just do that in orange because I like the difference of colors. So now that's going to be shifted 1 unit to the right, and it's going to be a V graph. A little low. Now this graph says only graph this for x values that are greater than 0, not greater than or equal to. So that's important because at x equals 0, there's now going to be a hole. It's not going to be defined. So I'll try to erase it, but I'm not going to get all the way there. So I'm going to have to redo that. So now at x equals 1, there's going to be a hole, and it's going to continue like that. So it's very important to understand that when you have the inequality greater than or less than, but not with the equal, then that's not going to be a defined value. All right, next one is we have y equals 1/2 square root of x. So that's going to be a vertical, vertical compression. So the square root function, if we know that looks, something like this, well, if I'm going to do a vertical compression, it maybe looks something like that, right? So let's just go ahead and delete the other one. And so there's what we're dealing with. Now it's saying that I only want to restrict this between 1 and 4. Interesting. So let's think about where would 1 and 4 be? Well, let's just pretend, 1 is here, and let's just put 4 here, right? So therefore, I only want to graph it between 1 and 4. But x has to be greater than 1, but not equal to, so I'm going to use a hole. And x has to be less than or equal to 4, so that's going to be a closed point. So therefore, my graph is only going to include this curve and the point 4. And then I can just go ahead and delete that, and I lost my y-intercept. So let's go back and plug that back in. Now let's go back into the Desmos just to go and take a look at that. There she is. Make sure that's good. So here's what my graph originally looked like. You can see the shift is being shifted 1 unit to the right. And then when I do my domain restriction, you can see here, now I didn't add a hole there, but it's just important that the graphing calculator is not going to be able to show you a hole. So you just need, that's why it's important for you to understand that's where that hole occurs, that hole is going to be. This graph, the y equals 1/2 square root of x, looks like that. And then when we apply our domain restriction, you can see that it's just that partial curve. And again, 4 is defined and 1 is undefined. So it's just important to kind of understand those points from there. All right, so now let's kind of look at our domain, or what exactly a piecewise function is. So basically a piecewise function is just a collection of 2 or more functions. So if you have a function, f of x, and we have more than one function and we're going to combine them or kind of bring them together, it's basically what we have a piecewise function. So I gave these functions, names, but technically really most often you're not going to see them as a name. You're going to see them as a rule. Kind of like what we did here. You can see here is a rule, right? So we have the rule and then we have the restriction. And that's basically what you're going to see here is rule and restriction. Now, for these two, I can actually combine these as a piecewise function. So let's actually do that. Let's just make up a piecewise function to kind of give you an example here. I like purple. It's a good day to be purple. So let's do a example here. Let's call this piecewise function. Let's do the first 2 examples, just so you guys can see what it would look like. So the rule is -x squared minus 1, and the domain restriction is x is less than or equal to 0. And the other rule is, or function, is 1 minus x, that looks really bad, with the domain restriction of x is greater than 0. Okay, and notice that this graph this function would pass the vertical line test, right? If you take these 2 functions separately and put them on the same graph, 0 is defined for this function, but it's not defined for that function. And then otherwise, these are all negative x values, these are all positive, so therefore that would work. So this is an example. In here, I provided you 3 functions, but a piecewise function can have 2 or more. There's no limit on the number of functions. But it is a function. So therefore, I wouldn't want to combine these 2 functions because you could see then they wouldn't pass the vertical line test. So therefore, it wouldn't be a function anymore. So therefore, that's why looking at the restrictions is really helpful to understand, where each graph or each function is going to be graphed, or at least where the domain is going to be defined. So when graphing piecewise functions, again, this really relates to what we did last class period. The main important thing is you need to understand, each of these functions that are provided and knowing what the parent graph is looking like. So that's something that we covered in last lesson, is understanding the parent graph and knowing the shape of that graph. Then, also what we covered last lesson was identifying the transformations, right? I covered the transformations of these graphs rather quickly for you. So it's going to be something that if you're not very strong with this at the moment, make sure you have that by you so therefore you can follow along and go through each of those transformations. And then the constraints on the domain. So we covered the domain and range of the functions, last lesson. And then just kind of understanding the inequalities and how these restrictions are going to affect your domain, which we're going to be doing a lot of little practice on. So now it's time to go ahead and get started with that.